Hi everyone, today we are going to discuss some searching techniques. Okay. So, last class we have discussed about some use cases on or case studies on searching and sorting. So, most of our time we spend in searching something or other. Okay. So, we need some techniques to do this process or operation in an efficient way. Okay. So, there are two types of searching technique. One is linear search and the other one is binary search. So, first we will discuss on linear search. So, from this name you can guess some operation we are doing in linear fashion. The other name for this linear search is sequential search. That is, we are going to do step by step, one after the other, one element after the other, that is linear search. Okay. So, this type of linear search can be done either in sorted list or unsorted list. Okay. So, I will show you both the way. First, we will discuss with an example of unsorted list. Okay. So, consider this list. Okay. So, this list is stored in array. So, you know variable array index starts from 0 to n minus 1. So, 0, 1, 2, 3, 4 and my search criteria is I want to search the item 4. So, how you can do by using linear search? So, first we will start from the first array element 10. You compare this 10 with this search item 4. So, when you compare this does not match. So, we move on to the next array element 5. Okay. Again you compare 5 and 4, again there is no match. So, you move on to the next array element. So, when you compare 4 is having a match with this 4. So, our search operation stops here and we display the position as 3. So, this 3 is array index plus 1. So, my array index is 2 plus 1. So, you get position as 3. Okay. So, see here you can see that we are going one by one item after the other item in a sequential order. That is why it is having the name linear search. Okay. So, if it is a sorted list, and through the same procedure you can go one by one and you can find whether you have found that element or not. So, this linear search has two output. One will be your successful operation, that is you will display the position of that particular search item in your list. Second one will be the unsuccessful operation. That means when you go towards the end, suppose here in our example we have searched the item 4, but when we are going to search an item 100, we start from the first element, then you go, if there is no match you go to the second element, then the third, fourth, until the end of the list you go on like this, and at the end you find that there is no match. So, that is your unsuccessful operation. There you will display the result as the item is not found. Okay. So, this is the main process of linear search. Okay, this is how linear search works. Okay. Now, we are going to implement this linear search in our using our programming language C++. So, before going to the programming language, first we discuss how to write the code through the flowchart. Okay. Okay. So, linear search, before going to the implementation of linear search, we just discussed the flowchart of it. So, you will start the process, then you will read the array, then after that you ask the user for enter the search item. Then you know very well array index starts from 0, that is why I have given I is equal to 0, I have initialized I is equal to 0. Then I will check whether I have reached the end of the list. If you have not reached the end of the list, then I will go to the no branch. Under no branch, I will check whether the current item is equal to the search item. If I have reached the end of the list, then I will print the item is not found in the list. Okay. So, in our case, if we assume that we have not reached the end of the list, so it is coming to the no branch. So, I will compare my current item, that is now the item is I is equal to 0 indexed item. So, that item double equal to search item. So, I will compare the both numbers. If there is a match, I will display the item is found in particular position. Otherwise, I will go for the updation of the next array element. Okay. Again, this will be continued until I find the item or until I reach the end of the list. Okay. This is the program for linear search in C++. Okay. So, you know very well we start with the header files hash include iostream.h, then hash include conio.h, and we have used we have declared a class linear search. Inside that we have private data members array, I have fixed the size as 100, then n I to be used in the loop, then to store the location I have LOC variables. Okay. Then under public session I have 3 functions, void input array to get the values of the array elements, and lsearch to search for an item. Both the member functions return type is void. Then I have a constructor which will initialize my data LOC. Initially I am setting LOC as -1. Okay. Then this is your main function. So, your program execution starts from main function. So, here to use this class I have created an object ls. Okay. So, how you create an object? Class name space your object name. So, ls is my object. So, I am going to insert values for the array. So, ls dot input array. So, what happens? My control transfers to this member function. So, inside the member function I am asking the user enter the number of elements. So, for simplicity I am choosing 5. So, this 5 will be stored in the variable n. Okay. C in n. So, whatever number I am entering, that will be stored in the variable n. Then after that, next cout statement is enter the elements. Okay. Now, using for loop, I have to get 5 elements. So, I need not write 5 cin statement. Instead, I am setting a for loop. So, you know very well array index starts from 0. That is why I have initialized I to 0. Then I will compare till I will compare this I with n. So, I less than n. So, what is my n here? N is 5. So, I starts from 0. So, it has to proceed from 0, 1, 2, 3 and 4. When your I becomes 5, I have to exit from this loop. Okay. So, that is why I have given I less than n, or you can write I less than or equal to n minus 1. Okay. Either case you can write. So, here I have used I less than n. So, my I value is 0 initially. So, 0 less than 5 condition true. I am executing the cin statement. So, I will enter a number, enter 10. 10 will be stored in A of I. So, this is my array. So, this I mark the index like this. Okay. Now, what is A of I? A of 0. So, if I enter 10, this 10 will be stored in A of 0. Okay. A of 0. So, 10 is stored in the array A of 0. After that, I plus plus. So, I plus plus means I is incremented by 1. So, 0 is incremented to 1. Okay. Now, 1 less than 5, again the condition is true. So, A of I, that is A of 1, I will enter 20, 20 will be stored in A of 1. Similarly, the rest of the elements, so 30, 40, 50. So, 5 elements have stored. So, after when executing 5 times, this I becomes, at the end it becomes 5. So, 5 less than 5 condition becomes false. So, your control return back to the place where you have called the function. Okay. After that, next statement is ls dot L search. So, your control transfer to L search member function. So, here inside the class I have given only the prototype, the definition is given outside the class. So, that is why I have used linear search, scope resolution and the function name. Okay. So, see out, enter the item to be searched. Next I will ask, enter the item to be searched. Okay. I am entering 30. So, now this 30 will be stored in the variable item. Okay. Now, again I am setting the I value to 0. So, again 0, n is 5 still. So, 0 less than 5 condition true, it is coming inside the for loop. So, inside the for loop I am comparing A of 0 with the item. So, A of 0 is 10. So, 10 is compared with 30. I am checking whether there is a match between these two numbers. So, here I do not have a match. So, again what happens? So, this if condition becomes false. So, your control go to the updation of I value. I becomes 1, earlier 0, then 1. So, 1 less than 5 condition true, again A of 1. So, what is A of 1? 20. So, 20 is checked with 30. There is again no match. So, again I plus plus, I becomes 2, 2 less than 5 condition true, again it will come inside the for loop. Inside the for loop I will check A of 2 double equal to item. What is A of 2? 30. 30 double equal to 30, it is true. So, if condition becomes true, so it is coming inside the if branch. So, inside the if branch I am allocating, I am assigning location variable to I. So, what is variable I? I is having the value 2. So, that is assigned to my variable LOC. Now, I will display the item 30. So, this item variable is having the value 30. So, 30 is found at position LOC plus 1. So, 2 plus 1, that is 3. Okay. Why I have given LOC plus 1? Because we programmers know that array index starts from 0, but the layman does not know from where the array starts. So, for them I just I just updated LOC plus 1. Okay. The value is not again assigned back to LOC, just I have made LOC plus 1. So, it will display the position 3rd. See, 30 is found in the position 3rd position. Okay. After this, I have executed the break statement. So, once the break is executed, it is coming out of the for loop. Outside the for loop, I do not have any this LOC double equal to minus 1 will be checked. My LOC is 2. 2 double equal to minus 1 is false. So, it is coming out of the if branch. After that, your function is getting ended. So, your control comes back to the place where you have called. Okay. Suppose you are going for searching an item of 100, what happens? This 100 will be sequentially searched from 10 till 50. So, from first to last you will not find any match. So, that time what happens? Your LOC is still minus 1. So, only when there is a match your LOC variable is assigned with the index I value. Okay. If you do not go inside this if branch, your LOC is still minus 1. So, that time this if condition becomes true. So, it will display the item 100 does not exist in the list. Okay. So, hope I have made clear to you all how linear search is working and how we can implement the linear search program using our C++. So, we have discussed linear search. So, that is very simple. It can be used in unsorted list. It works good for unsorted list. But the thing is, one disadvantage is it takes lot of time, because we start from the first and we move on till we found the item, or we go till the end of the list for finding the item. So, it takes a lot of time. So, that is the disadvantage of linear search. So, to overcome this, the second, the most fastest and efficient searching technique is binary search. It is following the divide and conquer approach. Okay. So, how this is possible means we will explain, we will see with an example. So, I have stored this much number of values in an array, and my array index 0, 1, 2, 3, 9. Okay. So, as I said, binary search proceeds using divide and conquer approach. The first thing what you have to do is you have to find the mid value, mid position of this array. So, what is the start index? It is 0 and end index is 9. Find the mid value, which is start plus end divided by 2, which is 9 by 2. So, it is integer, we will take 4. So, my mid position is 11. Okay. So, first thing you have to find the mid position, then you have to compare our search item with this mid position value. Okay. So, here I am going to search for the item 57. So, consider we are going to search for the item 57. So, what happens? Search item 57 double equal to mid position value is 11. So, it is not equal. So, what you will do? And one thing in binary search is your list must be, one requirement is there for this binary search, that is your input must be in sorted order. So, this is a mandatory thing, that is for binary search your input must be in sorted order. So, here example it is already in sorted order. So, after finding the mid position we will compare our search item with the mid position. If there is no match, then you will check whether 57 is greater than 11 or less than 11. Okay. So, we will check 57 greater than 11. So, if it is greater than 11, then our item will be in this second half, or if it is less, then it will be in the left half. So, we need not go and search the entire list, we can reduce our comparison by following this divide and conquer approach. You find the midpoint, you will compare the search item with the midpoint value. If it does not match, if it is matching, then you can display the position. If it does not match, then you will check whether the search item value is greater than the mid position value. If it is greater than, then definitely your search item will be available in the second half of your list. If it is less, then it will be available in the first half of your list. Okay. So, accordingly then what we have to do? We are going to, so from in our example we came to know that our search item is greater than the mid position value. So, here we are going to search in the second half. So, now we have to change our start index. My end index is always fixed, which is this 9 position. So, here my start index will be, so start index I have to change 0 to mid value, mid position, not value, mid position plus 1. So, what is mid position? Mid position is 4, 4 plus 1 is 5. Now, my new start index is 5 and my end index there is no change, it is still 9. Again I have to find the mid position of this list. So, 5 plus 9 it is 14, 14 divided by 2 it is 7. So, my now mid position is 25, this one. Now, again I will compare 57 double equal to 25, again there is no match. Now I will check 57 greater than 25. Yes. So I have again reduced my comparison, that is I have found that my search item is greater than my mid position value. So, my item will be available in the second half of the list. Okay. So, it will be available in this half. So, again I will again calculate the start index, again mid position plus 1, that is mid position becomes now 8. Okay. Start index will become 8, then end index is 9. Okay. So, 8 plus 9 it is 17, 17 divided by 2 8. So, my mid value is 57. Now, I will compare 57 double equal to 57. I found a match. So, I will display the item is found in the position 8. So, hope you have understood binary search. You have to divide, that means you are dividing the list into two halves. Then you will locate the middle position value, you compare your search item with the middle position value. If you found a match, then you can display that particular item is found in that particular position. Otherwise, you have to update the start index and the end index accordingly. If you find that your search item is greater than the mid position value, then definitely your value search item will be available in the second half. If it is less than the mid position value, then you have to search only in the first half. In our example, in the entire example, our search item is always in the second half. Suppose if an item is less means, then what you have to change in that case, when your search item is less than your mid position value, value in the mid position, okay, value in the mid position, then your data will be available in the first half. That situation, you have to change your end index value. Your start index will be fixed, which is 0, and your end index you have to change to midpoint minus 1. Okay, clear? Then you will search only in this first half. So, this is the logic of the binary search technique. Hope you all have understood. So, when comparing to linear search, binary search is very fast because we are reducing the number of comparisons. Okay. Next, we will see the implementation part of this binary search algorithm. Now, we will see the flowchart of binary search algorithm. So, you start, then you will read the array, then after that you will get the search item, then you will check whether you have reached the end of the list, that is the first condition. If you have reached end of the list and you have not found any element, then you will print item not found. If you have not reached the end of the list, then you will go inside the process box. So, inside the process, as I said, for binary search, first you will find the mid position. So, how you find the mid position? The start index plus the end index total divided by 2. So, you will get the mid position. Then you will compare the value in the mid position with the search item. So, here key means the search item. Okay. So, you will compare the value at the mid position with the search item. If you have found, then you will print the position and you go for stop. Otherwise, the next thing you are going for checking is, you will check whether the mid position value is greater than the search item. If it is greater, as I said, your search item will be available in the second half of your list. So, you have to change, in that occasion you have to change your start as start is equal to mid plus 1. Okay. If your item, search item is less than your mid position value, that time you will change the end index value, that is your item will be available in the first half. So, your end index will be end is equal to mid minus 1. Then again you will go and check whether you have reached the end of the list, and the same process goes on until I have reached the item or I have reached the end of the list. Okay. Once I found, I will display the position, otherwise I will display when you have reached the end of the list and you have not found any match, then you will print item not found. So, the main thing, you have to find the mid position, compare your search item with the mid position value. If it is matching, then you will display the item as found in particular position. If it is not matching, then that time you will compare whether the search item is greater than the mid position value. If it is greater than the mid position value, then you have to change the start index to mid position plus 1. Otherwise, you have to change the end index value, which is mid minus 1, and you continue the same process until you reach the end of the list. Okay, so this is all about the flow chart. Next, we will discuss the program in C++. Okay, this is our C++ program for implementing the binary search. So here, as usual, we have started from the header file iostream.h and conio.h. Then I have a class here. So the class name is bsearch. Inside that, as private member, I have given some data members. I have declared an array, then I, LOC, mid, item, beginning, end, n, etc. Okay. Then inside the public session, I have 3 member function. In the 2 is member function, and the third one is a constructor. So first one is by search. So this is what is going to do our binary searching algorithm, and input array is used to get the input items. Then in this constructor, I am initializing the LOC value to -1 initially. Okay. Then all these function is defined outside the class. So I have used a scope resolution and the class name to identify that this member is belonging to that particular class. Okay. So your execution as usual starts from the main function. So here I have declared a object bs for the class bsearch. So bs is my object, and using the object I am going to invoke all the function. So bs dot input array, my control transfer to this member function. So in that I will ask the user to enter the number of elements. So here you will be entering 10. So same example we will consider. So n will be 10. Okay. Now I will ask the user to enter 10 elements. So using the for loop I will get 10 elements. So these are the 10 elements 1, 2, 3, etc. Now after that, after executing this, the control comes back to the line where you have called the function. Then it comes to the next line, bs dot by search. So your control transfers to the by search function. So here I will ask the user to enter the item to be searched. I have entered 57. Then I am setting the beginning index to 0 and the end index is n minus 1. What is our n? It is 10. 10 minus 1, 9. So that is why your array index starts from 0 till n minus 1, that is beg is equal to 0 and end index I am initialized to 9. Okay. Then after that I will set a for loop. So inside the for loop my starting is from the mid position. So what is our mid position? Calculate the mid position. Mid is equal to beginning plus end divided by 2. So 0 plus 9 is 9, 9 divided by 2. So 9 is integer, 2 is also integer. It will take only the integer part of the result. So which is 4, 4.5, but it will take only the integer part. So mid position is now 4. Now then I will check beginning less than or equal to end. So this condition, this is the initialization step of your for loop. Then condition check. So what is the condition? I will check whether I have reached the end of the list. So beginning is 0, 0 less than or equal to 9, condition true. So it will come inside the for loop. Okay. So inside the for loop I will check item double equal to a of mid. So what is our procedure for doing the binary search? I will find the mid position, then I will compare my search item with the mid position value. So item is 57, double equal to a of mid. So what is a of mid? So 4 is my mid position. So this is my mid position value, which is 11. So 57 double equal to 11. Condition is false. So the condition is false. So it is coming to the next if branch. So here I will check item less than a of mid. So what is our item? 57. 57 less than a of mid value is 11. So here this if branch is 57 is not less than 11. So it will come to the else part. So else part I will reinitialize beginning is equal to mid plus 1. So what is mid? 4 plus 1, which is 5. So I will change 0 to 5. Okay. Then I will come back to the for loop. So for loop I will again, so that means I have decided that my search item, it is greater than this mid position. So, I have changed the start index to 5. See, now big is 5. Okay. Now, I have to search only in this portion of your list, second half portion of your list. So, I will go and update the mid position. What? I have to again find the mid position of this part. So, mid is equal to beginning plus end divided by 2. What is beginning? 5 plus what is end? 9 divided by 2. So, that is 14 divided by 2, which is 7. So, now for this section my mid position is 7. So, I have updated my midpoint, then again I will check beginning less than or equal to end. Each iteration I will check whether I have reached the end. If I have reached the end and my location is still -1, then I will display the item is not found. Okay. So, I will check this. If the condition is true, again it is coming inside. Again I will do the same process, that is I will match my search item with the mid position value. If it is equal, then I will display the item is found. Otherwise, I will recalculate the start or end depending upon the comparison, these two comparison. Okay. So, this procedure will go on. Finally, when I reach the end and if I have not found any item, this LOC will be still -1. So, that time item does not exist will be displayed. Otherwise, if we are going on searching by divide and conquer method, somewhere I will find the item, that is this condition becomes true, that time I will display item found at that particular position. Okay. So, item found at position, here LOC. So, LOC value is mid plus 1. Why mid plus 1? As I told for the linear search, you know, the programmer know the array index starts from 0, but the other person does not know from where the array index starts. So, that is why after finding the match, I will do mid plus 1, that will be stored in LOC. I will display that position. That means, if I find 57 at position 8, I will display that 57 is found at position 9 and break. Break means it will come out of the for loop. So, it will, after coming out of the for loop, it will check LOC double equal to -1. So, my case is LOC is 9. So, 9 double equal to -1, it is false. So, this part will not be executed and here your function is getting over. It will go back to the main function. After main function, you do not have anything. So, you are terminating the main function, terminating the program. Okay. So, that is all about binary search. So, coming to the advantage of binary search, it is fast, it is efficient. Okay. Comparing to linear search, it is having less number of comparisons. So, that is why it is becoming fast. But one disadvantage is you can apply this binary search only to the input of sorted elements. If it is an unsorted list, then this binary search will not work efficiently. So, there you can use the linear search. If your data is unsorted, you can use linear search. If your data is sorted, then it is good to use binary search because it is having only less comparison. So, your execution time will be fast. Okay. Hope I have made clear to you all both linear search and binary search. Thank you.